Hi, and welcome to this new video. We will discuss GMCanvas as a tool in science and mathematics. To highlight the utility of this tool, I have chosen the topic air drag and terminal velocity from aerodynamics. It is important to state here that it is not a lesson in physics. Rather, it is a video about a tool that could be used in facilitation of problem solving in STEM fields. A general problem in finding the terminal velocity of a freely falling object could be the one that is shown in the screen, in which a 75 kilogram skydiver is diving headfirst in air and has a coefficient of drag of 0.70 and a cross-sectional area 0.18 meters squared. And traditionally this question would be solved like this. Here is a ball that will be dropped from a certain height, and I have set this animation in a way that it is bottomless. That means it will not be hitting a ground. Let's take a look when I play the simulation. We can see that the object has a weight of 61.58 newtons and its speed is growing as the time passes. But something that we also notice is that the air drag is also increasing as the body speeds up, so much so that a time will come that both the air friction and the weight of the object would become equal, and whenever there are balancing forces on an object, its speed stops changing and the speed is approaching a constant value, represented by the flattening of the curve on the right. So this is known as the terminal velocity. We have to find that terminal velocity. Let's begin. This is GMCanvas. The formula for drag force is Fd is equal to half coefficient of drag, density of the medium, cross-sectional area, and the square of velocity. As we have seen that the terminal velocity exists only at a state where the drag force is completely balanced out by the weight of the object. So if I drop the drag force's value over here, it will replace it with mg. It is this intuitive manipulation of mathematical equations that this tool is so important. Moving on, we are interested in finding the terminal velocity of this object. So I will update this to the terminal velocity. Since we are interested in finding that, if I drag this fraction onto the other side, it will get multiplied, and it is pretty intuitive from here onwards. Or I drop this on the other side, I will get a formula for the terminal velocity. Now we need to define some unknowns here. The computer doesn't know what m is, so m is equal to 75 kilograms. The problem with this statement is that it has a g in it, and a g over here means gravitational acceleration, but over here it means grams. So to let the computer know that k and g is one thing, I will enter a long variable kg. Now you can see that it understands that it is 75 kilogram and not a kilo and a gravitational acceleration g. So this is how we differentiate between the letters that we are using so that the computer can understand our programming. Moving on, we have to define the value of gravity for Earth, which is 9.81 meters per second square. Another problem now is that this m is meters and this m is mass, and the computer cannot differentiate between that. So I will transform this line further and write a subscript mass of paratrooper. Now the computer can differentiate between m subscript p for mass of paratrooper and m for meter. Now we need to put the value of coefficient of drag 0.7 for a head-first dive. The coefficient of drag depends upon the type of shape that is coming in contact with the airflow. We can see that for flat shapes, coefficient of drag is greater than 1, and for a shape of a bullet, it is significantly less than 1, and for a sphere, it is one of the lowest. Now we need to define the frontal area, which is 0.18 meters square. Once all our variables are defined, the only thing left is to drag and drop the values. Now we can simplify this by multiplication. units can be dragged to the end. Our answer is 98.652 meters per second. Check it in the solved problem, it is also 98 meters per second. In my next video, I will talk more about this tool in which I can create animations that could assist in teaching and learning maths and physics. Thank you for watching.